Hi guys, welcome to this video looking at how you can use bond energy changes to figure out if a reaction is exothermic or endothermic. If we start off with the definition of bond energy then, it is nice and simply the energy required to break 1 mole of a covalent bond. So if we use methane as an example, which is CH4, it is the energy required to break 1 CH bond. Now the bond energy for a carbon-hydrogen bond is 413 kilojoules per mole. Now you will not be expected to remember that 413, that will always be given to you in the question, but what you need to be able to do is use it to figure out how much energy is needed to break all of those 4 bonds in methane. So to do that, all you have to do is look at how many bonds there are, how many CH bonds, which in this case is 4, times by 413 by 4, and it gives me 1,652 kilojoules per mole to break all the bonds in methane. So how can we use this to know if a reaction is endothermic or exothermic overall? There are 3 different steps that you need to be able to carry out. The first step is to work out the energy in, so that is how many bonds are broken, what is the energy of all the bonds broken. And then the second part is to work out the energy out, so that is all the different bonds that have been formed on the right hand side of your arrow. And then all you have to do is take the energy in, subtract the energy out, and that will give you your energy change. If the energy change is negative, it's exothermic, so heat is given out to the surroundings. And if it's positive, it's endothermic, energy has been taken in. So if we have a look at an example then, we've got CH4 plus 2O2 goes to CO2 plus 2H2O. If we look at the energy in to begin with, we've got CH4, which is carbon with 4 hydrogens attached. Each carbon-hydrogen bond has an energy of 413 kilojoules per mole, so that's how much energy I must put in to break one of those bonds. There's 4 of them, so 4 times 413 gives me 1652 kilojoules per mole. If we look at oxygen, that is O2. I've got 2 O2 molecules, so I have 2 O double bond O bonds. They have bond energy of 498, times that by 2, and that gives me 996. Therefore, my total energy in to break the bonds is 2,648. If I then look at my energy out, so I have CO2 and 2H2O. My CO2 is made up of 2 C double bond O bonds. Each of those has 805 kilojoules per mole to break them. Therefore, in total, I've got 1,610 to break all the bonds in carbon dioxide. Water, I've got 2 OH bonds per water molecule, which gives me 4 in total. So 464 times by 4 gives me 1,856. So if I then add both of those together, that gives me 3,466 kilojoules per mole needed to form all of the bonds. That's the energy given out. So if I then look at the energy change, I had 2,648 from my reactants breaking the bonds. I've given out 3,466. I subtract those from each other and it gives me minus 818 kilojoules per mole. And if you remember back from the beginning of the video, if it's negative, it means energy is given out, it exits, so it's exothermic. If we have a look at another example, so this is the Harbour process where I've got nitrogen reacting with 3 hydrogens to make NH3. So if we wanted to look at this forward reaction, I've got 1 nitrogen molecule and I've got 3 hydrogen molecules. The bond energy of a nitrogen triple bond is 945 kilojoules per mole, and my hydrogen is 436. I've got 3 of them, so 436 times by 3, which comes to 1,308. I add both of those together, it gives me 2,253 kilojoules per mole. If I then look at the energy given out, so I've got 2 NH3 molecules, that means I've got 2 lots of nitrogen bonding to 3 hydrogens. 1 nitrogen-hydrogen bond is 386 kilojoules per mole. I've got 3 of them per molecule, which gives me 1,158, and then I've got 2 molecules, so that is 2,316. So 2,253 minus 2,316 gives me minus 63 kilojoules per mole. Negative again, so it's exothermic. If we wanted to look at the backwards reaction, however, I don't need to recalculate the energies. All I'd have to do this time is take 2,316 away from 2,253, and that would give me positive 63, showing that the backwards reaction in this case is endothermic. Heat has been taken in. Okay, let's see how much you've picked up from the video. So I've got one question here saying, use the bond energies on the right, calculate if the following reaction is endothermic or exothermic. So you have CO plus H2O goes to CO2 plus H2. So just remember when you're doing this, if I've got CO, it tells you the type of bond over here. So it's going to be CO, H2O, you know there's two hydrogens, one oxygen, so you're going to have a HO and another OH bond. So you're going to want two of these, and then over on the left you're going to have a CO2, so that's two oxygens bonded to one carbon, so you're going to need two of these, and then you've got a H2, it's just one of it, so one HH bond. Okay, pause the video and have a go, we'll see how you've done in a minute. Okay, let's see how you've done. So if we start off with the energy in then, as we can see over here, I've got one C-double-O bond, which has an energy of 805. I have two OH bonds, which have an energy of 464. So if you multiply that by 2, it gives you 928. So your energy in, and you get your first mark for working out the energy in, is 805 plus 928, so getting 1733 gets you your mark. If we move on to the energy out, I've this time got two C double bond O's, which gives me 1610. I've got one HH bond, which we know is 436. So add both of those together for my second mark, which comes to 2046. The third mark is for the energy change to work out if it's positive or negative. So that is taking away this number here and this number here, which is 1733 minus 2046, which gives you minus 313. So the third mark is for that substitution there. The last mark, we know we've got negative, therefore it means energy has been given out to the surroundings. So what type of reaction is it? Exothermic. So the fourth mark is for saying energy is given out, it's negative, so it's exothermic. Okay, that is everything for this video. Hopefully that's made that a bit clearer for you. There is a review question, and I've given you the bonding here. It says use the bond energies on the right to calculate if the following reaction is endothermic or exothermic. And it's H2 plus O2 goes to H2O. Thanks for watching, guys. If you enjoyed the video, click on like down below. You can have a look at the latest video, you can visit the website, and you can also subscribe if you haven't done so already. Bye now.